So let's start with the chemical equation. So what is a chemical equation? What is the purpose of it? Chemical equation is a concise representation. What does concise mean? Minimum, small. Okay, we'll just keep it as minimum. A compressed representation of a chemical reaction. It shows how reactants convert into product, providing a shorter and more direct description of the reaction compared to a full sentence. Let's look at an example. Now, if I'm talking about a reaction, you don't have to understand the reaction per se over here, but let's look at it. The reaction between aqueous solution of lead nitrate and potassium iodine to form solid lead iodine and aqueous potassium nitrate. So this particular sentence I can convert to this, and this is your chemical equation. It's a symbolic representation of whatever is happening over here. As simple as that. Second example, we have combustion of methane gas with oxygen to produce carbon dioxide and water. Symbolically, how do you put it across? In this manner. Okay. Again, you don't have to understand anything over here. You just need to understand that this is done. As simple as that. Okay, guys. Now, let's move on. So, whatever we wrote over here, this can be considered as part by part. Everything can be subdivided. So let's look at one example. Let me take up the same example as what we written over there. CH4 in gaseous form plus oxygen. Let me do this. Actually, let me do all of this later. Giving out carbon dioxide plus water. Now, what is that we are looking at? Well, we are looking at reactants and we are looking at products. And this is an arrow indicating the direction of the reaction. This is your starting material. Materials. It can be single one. It can be a single item over there, or it can be multiple, like over here. And this is your, substance produced by the reaction. Substance produced by the reaction. And this is the direction in which the reaction happens. Direction of the reaction. Okay, so here is the starting material. This is the substance that is produced by the reactants, and this is the direction of the reaction. So this is your reactant. Right? This is your products. And this is your arrow indicating the direction of reaction. Now, there are a few more things to look into it. For example, C is your symbolic representation. It's a chemical formula per se. It identifies the substance basically. This we have already seen. Periodic table and everything. So this is your chemical formula. Then what else do we have? We have coefficients. So we have something like say 2 over here, and to balance it out, we should have 2 over there. So these coefficients, okay, they represent the amount of or the quantity of the material. It indicates the relative amount of each substance in what. So it indicates there are many things, right, happening over there. See, that's the point of a chemical equation. It indicates the relative amount of each substance involved. So here and we use a concept of proportion. Don't worry, we'll understand in time. Let me not bombard you with more information. And yes, there's one last thing that is to do with your status. Or let me put it this way. This is in gaseous form. This is also in gaseous form. This is also in gaseous form, and this also will be in gaseous form. So what does this indicate? This indicates the physical state. Okay. So basically, let me put it over here. This indicates the physical state. Again, we'll be looking into all of this at different places. This is just an overview. Physical state. Okay. Again, what is that we're looking at? We are looking at chemical equations. It's a concised way of representing a lot of information. We saw that, right? So if I have a statement like this, I can write it in this manner, and it not only indicates what kind of materials are getting involved, what kind of atoms and compounds and everything are involved, but also we can talk about the relative amount of materials. Like here, 2 oxygen is needed for 1 methane, right? A pair of carbon dioxide is produced while 2 pair of water molecule is produced. Right? Such proportion. So this helps in a lot of things. Actually, it's very practical. It also indicates the state of the material, right? So in this way, it helps in a lot of ways. And so we need chemical equations.